All right, here's the next section of this review. Probability distributions. This one to me is the most intensive as far as having to punch in a bunch of calculations and stuff. The first part isn't too bad. Uh, what I've done here is I pulled 100 casual college football fans. I don't know what that means, but there we go. So there are 100. And if you added these together, you do get a total of 100. And a probability distribution, what that does is it tells you the probability, um, like if you pick a random fan out of these 100, what's the probability that that random fan attended 0 games, and the probability that you attended that fan attended 2 games, and so on. So the probability, the initial part is pretty straightforward. It's simply the number of fans who fit in that category divided by the total number of fans. So 9 divided by 100. This one's going to be 14 divided by 100. This one will be 37 divided by 100. And you divide by the total number of people. And since I'm dividing by 100, it makes this very easy because anything divided by 100, you simply move the decimal to the left 2 spots. So first one is going to be 0.09. The next one is 0.14. The next probability is 0.37, 0.28, and 0.12. Most of the time you'll actually have to punch those in the calculator because very seldom do you have exactly 100 total people that are being surveyed or whatever. Alright, so there are the probabilities, and that's number 5. So number 5, I just constructed the probability distribution. Then it gets a little bit more cumbersome. Constructing the using this to compute the mean, and then using this to compute the standard deviation. This is where it takes a little bit more time. Okay, to compute the mean, it's not too bad, but to compute the mean, we need to put in another column where we do x times the probability of x. So my x column is the first one. That's how many games the fans attended, times the probability for that entry. So 0 times 0.9 is 0. 1 times 0.14 is 0.14. 2 times 0.37, and maybe I need to write those in there just to make sure everybody understands where this is coming from. So 0 times 0.09 is 0. 1 times 0.14 is 0.14. 2 times 0.37 is 0.74. 3 times 0.28 is 0.84. I think that's right. 0.84. And then 4 times 0.12 is 0.48. Alright, that's the first step in computing the mean. Now that doesn't tell you the mean, that's just the first step in order to get the mean. And then once you find that, you simply add all of those together. So to compute the mean, your mean is the sum of all of the x p of x's. So you add up all of the x p of x's, and when you add those together, the sum is, and we'll simply throw that in the calculator, so 0 plus 0.14 plus 0.74 plus 0.84 plus 0.48, and you get 2.2. Okay, that's going to be the mean. 2.2 is your mean. So there you go. You simply add those together. And 2.2 seems reasonable. That's going to tell you the average number of games attended by a casual college football fan, whatever that is. And if you look at this data, about 2.2 games makes sense. If you look at where they're all falling, the majority of them, or the largest category was 2, and then 3. So 2.2 seems about right for the average. Now the standard deviation is a lot more cumbersome. To compute the standard deviation, we're going to need the mean, which I may call the mean instead of x bar. I think I'm going to call that mu, if you don't mind. So I'm going to call this mu because it actually is the average of all 100. A little picky Math League of America thing. So we'll call that mu. And then the standard deviation, what we have to do is we take x, which is the number of games, minus mu, square that, and then you multiply that by the probability of x. So for this first column, or this first row, 0 minus the mean, 2.2, square that, and then multiply that by the probability of 0, which is 0.09. And we're going to do that all the way down. 1 minus 2.2, square it, times the probability that you attended one game, and that's 0.14. 2 minus 2.2 times the probability of attending 2 games, which is 0.37. And we'll do that all the way down. There we go. And then we need to calculate those things. And I would recommend that when you're calculating these, you do not try to... a lot of y'all feel like you need to do everything almost like you're on a scientific calculator, where you'll do 0 minus 2.2, then you'll square that answer, and then you'll times 0.09, which is okay, but you sometimes make silly mistakes accidentally by doing that. So when you're punching these things in, like that first one, 0 minus 2.2, and then times, or square that, times 0.09, just throw it all in one big swoop. It was parentheses 0 minus 2.2 squared times 0.09. And just throw it all in one big swoop, hit enter, and get your value. You get 0.4356. And that's not many decimals. I guess I'll write all 4 of those. Usually I round to the 3rd decimal, but I do that when I have like a buttload of decimals like I had up here for 67 over 79. 0.4356 isn't too bad. So I may just go ahead and write down all 4 of those decimals. So for this one we get 0.4356. And then I'll move down and I'll do the next one. It's 1 minus 2.2 squared times 0.14. So parentheses 1 minus 2.2 quantity squared times 0.14. Hit enter, and you get 0.2016. And so when I do this one, I get 0.2016. And then we'll do that for the other 3. All right, I just caught myself with a mistake. You have to be really careful with this. My first 3 are correct because it's supposed to be p of x, but if you notice right here, 0.84, that is not the probability for 3. That was my x p of x number. So make sure you look at the right one. That should be 0.28. Same thing for this one. This should not be 0.48. That should be 0.12. So be careful when you're doing this stuff. There's a lot of numbers floating around here, and it's easy to get confused. So let me erase this and put in the correct numbers. So that should be 0.28, and this one should be 0.12. So yeah, be extra careful with stuff like that because it's easy to get mixed up. All right, there you go. So I multiplied all of those together, and then to get the standard deviation, like we did with the mean, what I'm going to do now, my standard deviation symbol, my sigma looks stupid. There, whatever. Just like with mean, we're going to add up all of those numbers. So the sum of all of the x minus mu's times p of x gives you the standard deviation. So we will punch those 4 numbers in, 0.4356 plus 0.2016 plus 0.0148 plus 0.1792 plus 0.3888, and we get a standard deviation of exactly 1.22. So we add all of these together, and the sum is 1.22. That is your standard deviation. So there's sigma. Good? So that is your probability distribution, and using that to compute mean and standard deviation.